Hi, in this video we are going to talk about Sklearn, which is an automated machine learning framework and a drop-in replacement for scikit-learn estimators. This is very similar to Teapot that I have walked through some time back. In case if you have not seen Teapot, you can click the link on the top to watch it. But this is not that is not a prerequisite for this video. This video can be watched by itself. So what we are going to do is we are going to take a code and then see how we are going to take a data set and see how AutoScaleRn can be used for the data set. We are going to see some of the features of the AutoScaleRn and also compared with other frameworks that we have seen in the past. Basically, we have seen H2O AutoML, we have seen Teapot, and then we have seen AutoML. So all the three videos are there in my channel. You can watch it. We are just going to compare some of the differences so that it helps us pick the right AutoML framework for our problem statement. Now, coming to the code, basically the first line here over here, 3 lines, is to install AutoScaleRn. Basically, you have the requirements, that is a requirement.txt that has all the installation required for AutoScaleRn, and you need to run it before running AutoScaleRn. Now I have already installed it. It's going to take some time, so I'm not going to run it now, but I have already installed it. The notebook is available as usual in the video description below. So basically you can open the notebook and you can click open in Colab and you can run it by yourself. The software is already installed and I'm going to just start demoing the product here on. So the first thing what we do is we import all the packages required. Here I'm not importing AutoScaleRn yet. I'm just importing the regular machine learning typical packages we import for machine learning job, the NumPy, Pandas, basically the model selection package and everything. So I'm going to run it. I'm going to use the same data set that I used in the previous videos. This is basically a telecom churn data set by IBM. It is available in my GitHub repo, and the link for again the GitHub is in the video description, so you can just download the data set and play around. So basically I'm going to use the data set. Now let's just check the data set once. So basically the data set is about predicting whether a customer will churn or not. Now there are multiple features over here. There are features about customer like gender, senior citizen, partner, whether the customer has a dependent. These are all like features about the customer. There are features about customer product. What kind of telecom product he has? Does he have a phone service? Does he have a multiple line phone service? Does he have internet service? And finally, basically what is the charges he's paying, and finally a column churn that we are going to predict. So basically if the customer has churned, there will be a yes, and if he has not, then there will be a no. So this is the column we are going to predict, and this is a slightly imbalanced data set. If you check here, basically the not churned customer are like almost I think 3 times more than the churn customer. So basically it's a little slightly imbalanced data set. Now one thing about AutoScaleRn does not do the data pre-processing, not all the data pre-processing rather, similar to how H2O AutoML and AutoML does it. Basically when we saw AutoML, we didn't do anything with the data set. We just took the data set and we passed it on. Most of the columns over here are categorical column in this data set, if you see here. So basically AutoML and H2OML were able to automatically encode it numerically and then take care of it. But here it is very similar to Teapot. We have to manually encode those columns into numerical values. Basically we are doing a numerical encoding here, and then feed it onto the AutoScaleRn package that can basically do the right model selection and hyperparameter tuning. It does do some kind of data pre-processing, which we'll talk about, but as I'm repeating again, you need to do the numerical encoding. It does not take string values, it takes only numerical values. So here what I'm doing is basically I'm using the first thing, there are a couple of nulls in the data set that is on the column total charges. So I'm just taking that and I'm filling the null value with an median of that particular column. So that is what I'm doing. First is I'm doing an missing value imputation. The next I'm going to do is I'm going to take all the columns that are categorical value and then do an ordinal encoder. So basically I'm not doing a one-hot encoding. One-hot encoding is done automatically by Sklearn. What I'm doing is I'm just doing an ordinal encoder over here. So in case if one-hot encoding required, that is taken care. We'll see like how Sklearn runs different model. You can visualize that. But here I'm just doing an ordinal encoder. So all the categorical values basically will get converted into numerical values over here. Okay. Then basically what I'm doing is I am taking this converted value, and then I am basically updating the main data set. So basically the churn transformed is the column out of the ordinal encoder value, and then I am assigning it to an separate data frame, and I am updating the main data frame churn df, which we created here initially. This is the churn df. I am updating it with the encoded value. So basically if you see here in churn df, finally you will have all the values that are encoded into numeric. So there's no more string values. Everything is numeric over here. Only the first column is string, but that is an just customer identifier. We don't need that column for the model. So what I will be doing is I am basically creating an future data frame, and I am copying all the value, and then I'm creating the target data frame, and kind of taking the churn column and then populating it. Since I am using a pop function, it will remove the churn column from the future data frame. And then I am also removing the customer ID because that is not required for the model. It is just a sequence number. So pop removes the particular column from the data frame. And then one more thing over here is when we feed by default pandas, it will be of object type because it has string value. For Sklearn to work, you have to convert the columns to mostly numerical or categorical. So it cannot be object, it can be string or numerical. So what I'm doing is I'm converting all the value to integers since I am already encoded it. Right now I am splitting the particular data frame into 75-25 ratio. So in this case I am splitting into 75-25 ratio, creating an train and test data frame. And then now I am coming to the core functionality. I am importing the Sklearn package. This is a classification problem, so I am importing the classifier. I am going to run this 2 steps, and then this will take some time to run, and then explain the Sklearn classifier. I am going to run this and the next one and then explain it so that the model selection and hyperparameter tuning goes on in parallel. Now coming back to the AutoML Sklearn classifier. So basically we can specify some kind of parameters on what we want this particular classifier to do. So in this case what I'm doing is I'm telling it to run only for 120 seconds, that is 2 minutes, and per task, that is each model don't spend more than 30 seconds. The reason is AutoML packages are pretty compute intensive. If you don't kind of time box it and run it, will run forever, and it will kind of run for 2-3 hours to find the best model. We don't want to do that. We want to time limit it over here. But when in real world scenario, it's better to have an higher time to find the better model. But since this is only an walkthrough of the features of Sklearn, I'm just running it for 2 minutes. These are 2 parameters. The end job says like how many parallel threads you want to run. So in this case I put 2. Now include estimators. If we don't give any include estimators, then it will search across all the estimators. So there are multiple estimators. There are random forest, ADA boost, there is a k nearest neighborhood, there is an Bernoulli classifier. There are multiple classifiers over here, but in this case what I am telling is I am just limiting it to random forest and gradient descent classifier. And then the pre-processing component of it, if you want to run any PCA or any other functionality, I'm telling don't run any pre-processing for me in this case. So this is the definition of our AutoML Sklearn classifier to kind of give an parameter on what kind of parameters it need to run on. There are a lot of other parameters. If we have a imbalanced data set, if we want to do kind of an old out data set and everything, you can check the documentation, but these are some of the key parameters. And then what I'm doing is I'm taking the trained data set and fitting it with the AutoML, Sklearn classifier. So basically I'm passing the train and test data set. Now this has taken 2 minutes because that is the configuration it has completed. Basically it is giving that the classifier is completed. Let's visualize like what it has done. So first thing is show models. Now show models will give too much of information. So, but you can just print and see like what are the different models it evaluated, but it is not going to give a lot of meaningful information over here. And if you see here, it has kind of trying to do a categorical encoding also in some cases, right? But this print statistics is what we require. Basically what it is going to take is it's going to take the best model out of all. And AutoScaleon, what it does is it internally also creates an ensemble model. Finally, it takes all the models and create an ensemble model and then give the output. So basically the best validation score that we have got is 0.80. And within 2 minutes, it has done around 128 algorithm run. Out of that 127 was successful, and one because we are given the 30 seconds limit, one passed the limit and it got failed, right? So basically it has searched 128 models during that time. Now what I'm doing is I'm taking the best model and seeing what is the hyperparameter over there. So this command, right, automl.cv_results, and then I'm taking the argmax over there and then taking the mean test score. So this will give you the best model over there. So the best model that was selected is an basically SGD model, and these are the different hyperparameters that were used within the SGD model. And there were no pre-processing. Basically there was an one-hot encoding that it did for some of the columns. As I said, we are doing only numerical encoding. Let the AutoML framework figure out whether one-hot encoding is required. And then it is basically using an inch loss. And these are all the different hyperparameter of that best model that got selected. What I'm going to do is I'm going to take the test data set and then predict it. So we saw an 80% accuracy, I think, right? Yeah, we saw an 80% accuracy. So what I'm doing is I predicted with the test data set, and let me see like what is the accuracy on the test data set. So the test data set is around 81, which is pretty close to the validation score that we got. Now basically this is how we create the classifier, and finally what we can do is we can pick the model and then we can create a pickle file out of it that can be deployed in the pipeline. So what I'm going to do is I'm just going to import pickle and then pickle the I'm just taking the show models and creating the ensemble. As I said, this framework creates an ensemble of models, and what we are final model is an ensemble of models. Basically that's what we are selecting over here, and we are converting it to a pickle file. So if you go to the directory, you can see this pickle file over here. Basically what I'm doing after that is I'm just running some of the metrics on based on the predictions, like whatever the bin, basically 1367 are not churned and 394 are churned. Similarly on the test is 1312 and 449. There is definitely some difference over here. So let's try to understand like what are the, let's see a confusion matrix and try to understand like what are the false positives and false negatives. I also created a plot over here. You can go through it. The point I'm trying to make is this is a very imbalanced data set. So even though we have a pretty good accuracy is not a right measure over here. It should be like something like precision or recall, depending on what we are trying to solve, problem we are trying to solve. So basically if you see the confusion matrix, the not churn 1179 was predicted correctly, but at the same time like 133 were predicted wrong, and similarly for the other case. So if you see the final precision score and recall score, the precision score is 66 and the recall score is around 58. Now it may not be a pretty good precision and recall score, depending on the problem you are trying to solve, but with only a one line of code, rather than be running multiple set of hyperparameters and multiple set of models, we with just configuration and one line of code, we are able to come up with this model. And if you see here, I have not done any feature engineering at all. that is pretty key to any data set to give a better outcome. So basically, if I do some future engineering and again run an AutoML model, it's basically iterative process that I have to go through. It may give a better outcome over here. So that's it with Sklearn. In fact, like that's it with the AutoML series that I have been doing. I have reviewed like 4 different AutoML frameworks: Teapot, AutoVML, H2O AutoML, and Sklearn. All the 4 have some kind of features that are different from each other, and if you review my video, you can get it, and depending on your problem, you can use the right framework. Thank you.